So today's topic for us is cut your ELT/ETL costs without compromising on your reliability. It's a topic that we've been facing and having discussions about internally whenever we talk to customers, and that's the major concern, right? How do we actually make sure that we are getting the best out of our infrastructure with the most optimized cost perspective? Keeping that in mind, we have Arav with us here, and Arav has been with Hevo for the longest time. He's a senior product manager. He's an expert on how Hevo functions and how data integration industry is functioning right now. Thank you so much, Arav, for joining in. And just to give like a quick agenda overview, we will talk about why knowing your cost is very important. We'll do a TCO breakdown. So what does your total cost looks like? How does Hevo help in optimizing your cost? What does your roadmap for efficiency should look like? We'll give a Hevo demo where we'll show where all you can save costs and how we actually impact costs at the end of the day, and a couple of best practices from our side. Arav, I think you can take over and show everybody the topic for today.
Thanks, Radhika. Hi, everyone. Thank you so much for joining in. Really happy to lead this through. So, as we jump into uh, what our costs are for a ETL or a data platform, we have known, I mean, that's one of the first questions that comes in, right? How much does it cost? What's the actual true cost of you moving your data from point A to B and then getting extreme value out of it? It's not just about the ROI, it's first about actually attributing what is that I'm actually paying for. So there are three broad categories in which your actual data platform costs are, right? So there is a part where you are moving your data. There's a part where you're actually putting in some effort, and then there are constraints around it. So first, let's start with what why knowing your costs is important. So with all of us run with limited budgets, pretty much predefined connotations on what how much do we want to spend on anything through the year, right? So we try to set apart, okay, this is what my data movement cost will look like, this is the cost of my warehouse, and this is the most probably predictable cost for uh, my actual downstream workflows, my compute, my ability to actually run my analytics and get insight out of it. Uh, Within all, while all of it this happens, we actually in between we all know we run into, hey, my credits are actually about to expire on Snowflake, or my BigQuery bill suddenly came out to be two times of what it was last month, and suddenly we are not sure how we are going to get our ends meet, right? So how are we going to ensure that we stay within budget and we don't actually overspend, as well as we don't trigger actual decision which eventually impacts some kind of other expenses within the organization. So that taking that into account, we thought that this will be a pretty useful session for us to understand what contributes to costs within your ELT pipelines and how Hevo helps you actually optimize them. Uh, so whenever we run into this, even today, like with some of our customers who, or some of the prospects who come to us and they have like, they got a really high bill from their existing ELT vendor and they don't know how they're going to actually manage. They went from a bill of something like 100K to 300K over a period of time. And they, like within a period of 1 year, and their renewal is coming up and they don't have that kind of budget approval to even support it. Further, this also ties in that their Snowflake budget bill has gone up by X amount, plus their DBT cloud bill has gone up by X, or their number of users has increased and their billing model has changed. And all of this with lack of predictability leads to a situation where they are negotiating within internally, what do we do with this? How do we manage our data stack? So to avoid such things, right, we go into what do you actually need to do. So we break down your TCO into three parts. From a ELT perspective, one is the tool itself, right? A tool like Hevo or any other ELT vendor that you're currently using, or even building pipelines internally or using something like AWS DMS, which is like in-house managed but does certain pieces of things. There is a consumption-based pricing, there's a license-based pricing, there is even something, there's open source, there's a cost for you hosting it internally or on maybe lending it something on from cloud. And then there is a warehouse cost. Now, warehouse costs are also broken down into three parts. First one being of your data movement. So how efficiently are you able to move your data from the actual source, something like Postgres, MySQL, to actual Snowflake? Is it efficient? Is it optimized? And then the secondary cost of it is how are you actually querying it? So that comes into compute in terms of are your workloads efficient or not? Are you actually overcomputing in terms of how often are you running it? What's the cost of it? Total compute costs. Who is actually querying it? Are they querying it efficiently or not? Are certain tables refreshed more often than they are required? You try to answer all these questions while managing your overall warehouse cost. And the third is the actual maintenance and development overhead for this data platform itself. So when you maintain it, how high touch or low touch the platform is? Does it need like you to intervene every week because hey, my data is not right and my stakeholders come back? Why is the data not correct? And you're going through the whole cycle again. Did something break in the pipeline? Did I get an alert? Do I need to raise a ticket with the vendor? And throughout all of the cycle, you try to figure out, am I actually spending more time managing that pipeline that I've paid for, or actually the pipeline is working without with you focusing on something better, right? So we'll break it down how we fit into each and every stage and what happens there. So essentially, we what we do is that uh, we start to be first. We try to make the first part of the process a bit more predictable. Uh, Currently, how the market works, we have different pricing models with something ranging from unique row based billing to consumption on size, with a mix of consumption of events, with a different kind of billing on consumption by let's say uh, compute. So we have different models, and each of those models become fairly hard to predict as you grow as a company. And there is a direct correlation. There could be, may or may not be, direct correlation with your growth versus different uh, billing models that you're actually relying on to actually grow or not, with multiple other factors also kind of playing into your bill. It could be org size, it could be your uh, which kind of connectors you are using. So to try to make it predictable, we are fairly simple and transparent in our pricing itself. So it starts with the first step itself. We go with a very simple pricing of event-based consumption, which has uh, logarithmic graph where as you go consume more, the cost per event goes down, and we kind of are pretty much dependent on exact number of events. And number of events here refers to an update, delete, or uh, uh, like insert, update, delete. So this pretty much ensures that you're only paying for what you are doing, and there is no baked in cost upfront. Hey, an event updates so many times, so I'll pay for that. Or you knowing how my average record size actually exists, right? The reason for that is that if your record sizes are higher or lower, we kind of handle for it at our end, leading to pretty predictable pricing. So if you're in, let's say your customer, you have a table which is dependent on number of customers and certain activities that they do, it will pretty much linearly grow with how fast you grow, not exponentially based on some other factor. The second is how do you actually optimize your warehouse. So one optimization is actually done by the vendor itself, that is us, where we understand how these warehouses that we are interacting with best load, and we spent a lot of time, rather of like a couple of quarters, experimenting with each and every warehouse with different query load patterns on how we should actually be loading data into the warehouse, and what causes for different types of workloads, what causes the best. like rather the cheapest way to load into that particular warehouse. So after spending a couple of quarters experimenting, we came up with different strategies with different type of workloads as well as different warehouses on what we should be doing. It could be dependent on file type, file size, when do we load, how do we actually define certain type of metadata on on the warehouse. And this led to significant improvement, which we will certainly showcase as we compared ourselves to other vendors across different scenarios. So there could be scenarios of how often do you load when you were doing a very large load, and depending on such use cases, we came back with an actual benchmark as well. And the third part to the warehouse part is how do you actually consume it? So that consumption itself is dependent on how well do you load the data. If the data is not initially clustered, partitioned, or organized in a way where your query patterns are not actually planned for, you will end up paying more either in reformatting that data into a better queryable format, or you will end up costing a lot more because the query pattern itself is inefficient. Uh, a bit more on very specific details on what to do with every warehouse later, right? And the last part towards it is we have actually moved toward very different model in terms of how your pipeline gets managed in the future. That pretty much means that we have built in a lot of inbuilt observability on each and every incident internally. So what happens is if your pipeline is running and even if you get a single impact or single outage for your pipeline, we have an internal trigger that goes in and without even you knowing and or your customer knowing before that we know, and we are actually already going and fixing if there is some kind of let's say unexpected event that happens with the pipeline. So to reach till there, right, from a state where we need to know the moment there is any concern with the pipeline, we are actually able to look at it. There was a very long journey, and that journey started with us putting a lot of instrumentation internally. It all tied in into having a very reliable product, but also ensuring that you don't really have to actually uh, pay with your own money when you're, or time rather, when you're actually spending time in maintaining this product. So it has to be as low touch as possible, and that's what we take pride in. Like the best of the days are when you don't even have to care about us actually running underneath and you're not caring, like any other core service like electricity, water, or internet, as we see, right? You don't expect any of them to go down. And similarly, we have been working very diligently towards reaching to a place where even if there is a small, slightest of the impact, we know it first and we go are actually going and taking the corrective action or fixing it or actually mitigating the issue within a few minutes. So with that in mind, we are targeting fairly stronger SLAs. We are managing fairly high uptime standards, and we are moving towards make kind of making them public in nature. Coming back to the benchmarks, right? So this is one of such benchmarks. We have been running these for the last 6 months across fairly aggressively in terms of scale, size, and testing. How do we actually perform out there? In this case, this is a comparison of a Snowflake historical load, which will happen when you're actually doing it for the first time, or there could be any scenario where log expires, or you just need a full refresh, right? Now, different tools take different approaches. This is a very basic historical migration kind of workload, uh, talking about 383 GB in total, about 550 million records with uh, a fairly large number of objects and a mixed row size with a fairly complex structure underneath with a lot of nested arrays, JSONs, etc., which is like representative of any of your true workloads, right? And we took that in, we ran a fairly large historical workload on us, on other enterprise heavy tools. Ran it on open source platforms. We ran it on certain cloud native streaming kind of tools. We also ran it on certain legacy tools which used to exist, uh, or rather, I'll say, have been there in the market for 10 plus years, built on some kind of open source and acquired and went through different cycles, right? While we were running this test, we essentially we are almost 40% better than the nearest competition for a fairly large load at a fairly large scale. And performance wise, we are nearly comparable, or in certain cases, are really faster than the rest of us. But the main aspect is the impact that we had on your Snowflake credit consumption. Now, the actual compute credit consumption in both the cases, we were about 50% lower than the nearest competitor. Uh, the question is, how did we actually achieve it? Now, if you might know, Snowflake's credit consumption works on how often, like the warehouse runtime. So the more the warehouse runs, the costlier it is. So uh, in certain cases, we saw very inefficient load patterns where people were loading anything whenever the table was ready, which led to really high consumption or like certain smaller tables getting loaded at once. And we saw warehouse costs pretty much bouncing really high for no reason for a fairly structured load. So they were running the warehouse approximately 20 to 25 times more often than it was actually required, and that led to a fairly large cost. In the other case, we saw the extreme where uh, like the way the load happened itself uh, was like not in the right format. The files which were staged were not in the most efficient case, and like we kind of understood why they were there. But at the end of the day, we were able to prove, and we were able to actually benchmark to a fairly lower cost, which actually frees up a lot of your budget to actually use it for actual compute, but not the ETL part, right? So the actual value is not in just moving the data, but rather you being able to query it efficiently, run proper models on top of it, do machine learning, get some actual insight out of that data, your customers being able to use it, right? So that's what this generally frees it up for. This frees up your Snowflake commit. You already would have had something for a yearly annual commit, and this frees up that number for getting actual value out of that data rather than just getting it to a place where it is ready to use. Um, Coming to mm, the next thing, right? Like how we are actually optimizing it. So the first part is that ETL costs are not only on loading, they're also there on your source. When you are dealing with something like, let's say, an Aurora or a serverless system, if the ETL, if you're doing it very aggressively, any auto scaling system will actually consume too much resources, and that unboundedness of you being too aggressive could lead to a even larger bill than you can anticipate, because scaling for Aurora does not happen in a way where it will downscale as soon as it is ready. It will actually autoscale fairly high, and then you're kind of paying for a lot more compute than you would have estimated for, because the resources were provisioned, and uh, by the time it downscales, you have actually exceeded something. So to accommodate for that, we have built in certain guardrails on how we actually query, which creates more of a very lightweight or a on your low impact querying on your source when we are doing historical as well as incremental workloads. Of course, source efficiency is a lot of times more towards when you are doing a bulk load, but it can also be there in terms of when we are doing some kind of custom query or table mode based pipelines where this impacts. The second is the impact that a tool can create just because there is limited uh, capacity on the source itself. So for a fixed capacity resource, something like RDS or something which third party vendor is owning, if you're doing it too aggressively, generally you will either bring the source down itself, or if you're not going there, you will actually impact your own business, because the responsiveness of that core key system in production has actually reduced. So to prevent that, we have again put some kind of guardrails in terms of number of connections, and we have very high flexibility in how aggressive or passive we want to be with this. And that can be figured out manually, and we even have some automated ways to actually scale it up. So we try to get what is the instance capacity as well as how much volume do we have to load in. And we have an intelligent system which takes into account how aggressive should I go during the initial load itself. And that stays pretty much with us in terms of how we provision resources. And it can go up and down depending on whenever you do a historical resync. So it's not like something that we store and maintain, but rather every time we have to do it, we do figure it out, and we kind of tweak ourselves automatically on how aggressive or how passive do we have to be. And then on the load side, we optimized primarily for different warehouses. We took a different approach. So Whereas on Snowflake, you had the bigger problem of how easy, how often the warehouse runs and for how long. In BigQuery, the problem becomes on the scans. So if you're doing a scan inefficiently at any time during the merge, uh, you will end up costing, will end up costing you more, right? And the cost of, again, your GCP credits consume more, and there is lesser actually bucket out of there's lesser of the pie available to actually do compute. So we did different types of batching. We have certain changes in how we actually load data across these two different destinations and leading to a better actual output in terms of costing. We also added a case where, let's say, you don't need to do a merge, which is common, where you see you want a fresh start, you want to drop everything. We baked it in the product itself, right? A lot of times you don't have the capability to even run a drop query on your system, or you have to go through a different process. You get it out of the box in the product. If you need to take that action, that is pretty much makes it an insert only query. So there is no merge. It's fairly efficient, even if you have to do a full reset, which happens in a lot of sources which are, let's say, stagnant in nature or are a snapshot of their own. They don't need to actually capture anything else. They just need to run or drop a load. You have that flexibility as well within the product. And that was thought through just to ensure that we cover as much of breadth of different types of use cases. And the third part of it is us in our pricing, right? We do have consumption-based pricing, which is pretty much you pay only for what you uh, actually consume, right? You can, there's no like a minimum comment. Of course, we have plans which offer a better piece, but you can always go for a truly consumption-based pricing, which is fairly easy and pretty much a linear scale, which you can predict how much your bill is going to be every month. And there's no surprise on why did I go so far. The other part of it is we also allow you to actually consume our AWS or GCP credits to go via these marketplaces. So if you already have purchased certain credits which you want to consume, we have a fixed budget in terms of your credits. And if you want to use any of these routes, we certainly have that available as well. And we are also going towards the Snowflake uh, MCD billing availability sooner. So there comes the roadmap, right? There are some things that are already available for efficiency, and then there are some things that we are trying to do to even make ourselves better than we have today. There is a consistent focus on with each of our scale runs that we measure how much cost is on the warehouse, and if it has any tweak, we pretty much monitor it. But on an ongoing basis, we have certain features that fit into our roadmap in the next couple of quarters, which help us be even better than we are today. So today we are adding support for clustering keys. We also have like recurring benchmarks which are currently live. We have an automated run happening on ourselves, and we are monitoring our trend on if we are going higher, lower, and if anything changes there. Further in BigQuery, we already have support for ID-based partitioning. We are also adding time-based partitioning in the coming quarter to actually support even better querying capabilities. And for you to, if you, let's say you have a time-based database, then we ensure that your data is actually at rest in a way, or when we are merging it is in a way that we are scanning the least amount of data possible for it to run. Um, with this, we'll jump into a quick demo, look at what Hevo looks like, all the capabilities that we have around, let's say, monitoring your own consumption and cost, and going through some more details of the product. So I'll start by building a basic pipeline, what it will look like, how easily you can actually get onboarded onto Evo, and from there I'll go into a bit more detail on what you see, how do you actually consume it. For the sake of the demo, I'll start with the RDS pipeline with a fairly simple Snowflake as a destination. And okay, we'll give it a name, add the user and the password. So this is a CDC based pipeline. Here we are going to consume data from Vol. What that means is that to set this up, you need to set up uh, your Postgres, and you have to enable write ahead logs, which requires certain changes when you are enabling the database. This is a normal master instance. In Postgres now we also support replicas. So if you have something like a PG 13 or above and you have a replica instance, we can actually support sorry, PG 16 or above. And if you have a replica, we can actually replicate it from uh, the replica it's as well. We can have a pipeline from there. Uh, Further, uh, to even ensure there is no impact to your source system and taking the insight that we don't want to increase your storage or cost, we have something called as log size monitoring in Postgres. What this means is that you can set a threshold on a size of the wall. So in this case, let's take it like 200 GB. If my wall size grows above this particular size, I'll set a threshold. So let's assume 80%. So what this means is the moment I cross 160 GB, I'll start getting alerts if I enable this. And if the size crosses 200 GB, the pipeline will be disabled with us actually dropping the slot and ensuring there is no harm to your database. Further with this, we also offer a bunch of connectivity options, which I might not explore during this call, but we already support. If you are behind a SSH, if you need your connectivity using a VPC, we can support it out of the box, pretty much by setting up the VPC or uh, doing a SSL, doing reverse proxy. So all such capabilities are kind of available already within the product, uh, offering even better control as well as security for your data. As you configure it, you can always pretty much easily see for each and every source. We have a detailed document on what needs to be done. And if you get stuck, you always have the capability to do a live chat during pipeline creation. For the sake of the demo, I'm using uh, destination that I'd already created. But we take very basic information around your warehouse, database name, the username, password, or the key pair, as Snowflake has been pushing for it. Uh, and you can also have the control of do you want to quote your tables or not. Uh, Quoting here means that we load data as is. While we are moving data in a normal scenario, we do some kind of sanitization to ensure that if there are any special characters, they are well handled, and there is any conflict of name, or if there are any reserved characters that are present in the source, we kind of change them to the relevant name so that there is no impact to the pipeline and all of that data moves directly. So if you need the data as is, you kind of enable this flag. Otherwise, you can keep it turned off. Uh, so with this, we'll just move forward. We'll just do a test connection, see if I can actually reach out to, I can actually test the database or not, since it's available. And now I get to name my pipeline. So I'll just say uh, for the pipeline. Then comes a prefix. The prefix here is a prefix that we add to the schema names that we create. In this case, I'll just give it DD as is. And so let's say if my schema was public, then I'll have a schema created in my destination as DD underscore public. Further, you get to control what do you want. Do you want merge or append across all pipelines? So what merge means is we'll actually run a merge query at the end of the day, and append means that we'll do an insert only. Uh, of course, append will be cheaper, and if you're looking for a case where you just want to track each and every change that happened within the database, append will be the way to go because it will pretty much create a entry for each and every change without actually looking at the primary key. A merge here will actually take the primary key into account and load the data. And if you even select merge and the primary key does not exist at source, instead of running a merge query, we will be efficiently running only an insert query. So that is also an optimization to ensure lower costs and lesser number of scans in your warehouse. At whatever stage, even the minutest, like it may or may not impact so much, and in certain cases it will have a significantly higher impact if you have too many tables with large data but no primary key, but rather only indexes existing. right? So we kind of optimize for it. If there's no primary key, we pretty much go for an append automatically. Further, you get a control on what happens if the data is actually incorrect or failing. This follows the principle that we try to do best effort loading as well, as much as possible. But if there are too many failures, it's better not to load data and then inform you and then take the corrective measure rather than loading everything and then causing a downstream impact. And already things would have ran, which could have led to a different kind of failure. So with this, we have two modes. You can actually stop loading data for all the object for the whole object if any event fails, or we can do a best effort loading till a particular threshold, and then and if we still cross that, then the object fails. Further, you get control over how the schema evolution happens for the pipeline. Should we add new objects, uh, new schemas, new columns, or nothing happens, or you can only add new columns, but schemas and tables are actually skipped. Further, you also get the option, do I actually need to move my historical sync or not? This is for different kinds of scenarios where you may or may not need your historical data, and you can take that call as per your expectation. The next set is you set how often do you want to run the pipeline, and you can also get latency based alerts. We'll spend a brief moment towards when we look at an existing pipeline on what does latency based alerts mean, but you can actually set how uh, much of a delay is acceptable for you as a user and for your downstream systems and your customers, and you get a full free hand to actually do this. So let's say I put 65 minutes as a possible uh, or in this case, since I'm setting a pipeline for 1 hour, you get a 120 minutes as a possible latency threshold. So um, what will happen is if the actual source to destination time increases by a certain limit, we kind of send an alert, but we'll see how we compute latency and actually showcase it in a very observable way. I'll just select all possible tables that I have in this database. I think it has about 105 tables and a fairly small load. So it will take a couple of minutes and I get to review everything what I've set up. If I need to change any of the settings, if we think that, okay, do I need this monitoring or do I want to change anything else? We can of course go back and change it. Otherwise, pretty much save the pipeline. While this pipeline runs, we'll just quickly switch over to pretty much, you can assume one of our broad pipelines that we look at. And it is moving certain data from uh, a database uh, to a BigQuery warehouse. Now, while we are moving this, you will see that there is a job that is actually created every 6 hours, and there is a threshold of a latency or max latency that you see here. So if you go in a bit more detail of that job, what does the 6 hours mean? So this is the minimum, maximum, and mean latency for this particular job. What this means is for all the records that moved in through this job, approximately 2.16 million, how much was the oldest record? See, since the data is moving every 6 hours, the minimum latency, rather max latency will always be almost up to 6 hours if I'm generating data every minute or so. So it is from when the data was generated at source versus when it was actually loaded in the destination. The truest difference between your source and destination, giving you a very clear observable way of what it means. Further, for each and every job, you can see details on how much data was loaded by which particular table, uh, till where did it read it till, and generally, if there are too many objects, you have control over filtering, sorting on different capabilities, as well as you can search. Further, you also get a detailed session log, which is like you being able to see what is happening underneath. It's a aim towards transparency, observability as a product, and as a basic principle that whatever we are doing should be pretty much common knowledge for anybody involved using the product. Uh, you can also see a detailed activity log, what happened to the connector over a period of time, who changed something, was there a state change, if a pipeline change completed with failures at certain point, right? You get to see that as well. So further, I'll just go to a job which actually had a state of completed with failures to see what does a failure look like. So in this case, uh, certain records failed for whatever reason, right? Now, in this case, you get a very clear reason why did it fail. Since there is a load level failure, there is not much to do, and generally, uh, there was a permission related issue, and in the next subsequent run, as a minute retried, it actually recovered. But this is how it becomes fairly easy and predictable for somebody to look at the product, get a sense of what went wrong, and then take a corrective action, retry it, or if there is any action that needs to be taken by us, we are also able to take it upfront itself with a very detailed job view as well as ability to monitor it. Um, coming back to coming back to our ETL and ELT costs, right? So the pipeline that we create has would have almost started and it's kind of in progress and it's running in the first historical type of flow. So that's it. That's how easy it is to actually get started within the product and get a pipeline running with most of the information available. Uh, and we'll go back to co- coming to the best practices and what do you actually need to do to become better at monitoring and managing your costs. So the best practice of number one comes with monitoring your spend, right? So there have been multiple attempts by different folks to actually solve it and different points. One of the earlier problems, I'll say, started with somebody, we did not even have very good visibility into why my Snowflake costs were there to a certain extent. I think by itself, all the warehouses have become a lot more transparent in their costing, what is costing them, which query is costing you, and it has become a lot more easier. It's not like you have a lot of pre-built queries to actually get where your spend is going in. So the first step comes in, you need to monitor the spend. So coming back to a bit more towards Evo, you get detailed usage reports for each and every pipeline that you have, and you can pretty much set up alerts on a particular pipeline if you are actually exceeding a particular threshold easily. So you can monitor the consumption, you can set a threshold for the consumption, and that is where you actually get to a place where there are no surprises. Uh, the second part is the schema fixes itself. So uh, there are two parts to this. One is if you have built a pipeline in-house and you are using something which something like Debezium or some other tool where your schema is not directly in your control and you won't have a very complex schema engine to actually modify things in a particular way. So there are two parts to it. There are some things which are promotable in different warehouses, and then there are things which are not promotable and pretty much need a restart. So uh, that depth of understanding and kind of ensuring that your schema evolves in only when it is actually required. Also, when it evolves in the most efficient way. For example, we have done certain efficiencies that we should not be needing to evolve your schema in a breaking manner. I'll take an example of precision and scale for decimals. Changing of decimal precision scale in Snowflake is a breaking change. If you have to do it, you pretty much have to do a column hot swap of sorts, which leads to a very expensive uh, operation if the scans are really large. So earlier we had different approaches to actually solve for it, and we eventually broke it down to a certain way where we were trying to reach the best possible configuration in the first go, rather than going through this evolution process. So understanding where you can actually do the best possible fit and then promote schema evolution or evolve schema accordingly, rather than where you want to reach the terminal state from day zero, because it's not going to impact your storage, but rather future evolution is the other piece to it. The other is setting alerts and logs, right? So uh, setting up relevant alerts on cost monitoring uh, for your Snowflake, for your actual AWS bills, for your other cloud costs, uh, all together kind of add to uh, ensuring a better uh, I'll say cost efficient data platform overall. And the last part is making pricing predictable. So with different pricing models, I believe some are easier to manage than the other. Compute-based pricing, of course, being the most common one in the world of cloud, is easier to do when you're doing continuous computes, where your computes are kind of more reliable or they're predictable in terms of your jobs, what they're happening. But on the other side, the other extreme, you have something which offloads uh, things uh, in the world of ETL as how should I put it? So it pretty much masks it in a way where you cannot actually predict what my monthly bill will be for my data movement, because I don't know what it is computed on, or even if it is computed on something, I got a bill shock just because the pricing model had changed for the vendor. So both of them combined together leads to you choosing a product which is more predictable. Either it is a basic license, it is a better commit from them, or just their gentle practices on transparency, leading to not just on the ETL side, but on your transformation as well as license management side. So that uh, one of our case studies on what one of our recent customers actually got a pretty good reliability and cost savings when they actually moved to. They're struggling with four primary problems, right? So they had high maintenance costs because they were running on something which was fairly old. And they were continuously going back and forth between certain capabilities that were not available within those vendors and those connectors. They had high costs because uh, uh, it kind of strained their own team, right? Uh, they they were continuously spending more and more on restarting the pipelines because they were broken, and that led to them losing out on time, money, unavailability of data, and this pretty much led them to be looking out on something else, right? So it was not scaling as much. It was breaking down often. Even if it was breaking down and they used to trigger a restart, it was taking too long to finish the restart. And while it was doing it, it was costing them on both sides, on the infra, on the source, on the destination, as well as their own time and money. So this led them to actually come back and say, okay, what do I need to do? So they were bringing in multiple sources. There were certain capabilities that we had out of the box, certain capabilities we did not, like Jenkins, we did not support or we did not have. And then we built something, a custom connector for them or a custom REST API connector for them to actually solve that problem. Then they use different sources like Salesloft, Intercom, uh, to actually get in their customer interactions. They had data coming in for actual product utilization from Pendo. They had their internal team management as well as developer delivery management in Jira. They had certain webhooks which were coming in from actual production customers, and then they had their CRM as well as a lot of internal generic sheets which they were trying to use as reference data to populate and analyze how things were going. Further, they had their own actual product uh, production databases, which had data around their product utilization as well as general product data around their customers. They used all of this to bring it into Snowflake. They had a transformation pipeline which was triggering via DBT directly on top of it. And finally, they were actually able to move all of their data continuously, reliably, uh, achieving significant cost savings in the whole process, and pretty much not looking back from there. So the overall costs, like from whatever their bill was from the earlier vendor, plus their Snowflake, plus whatever they were paying, it came down to approximately by 85%. With this, they also had a significant availability of support, a lot of time to easily move their pipelines in a very in without actual any impact on their downstream systems while we were doing this, because we were helping them migrate from an existing vendor to a better one. And then they had no escalation, zero downtime, and their overall costs went down while their data scale continued to increase. So whatever they started with us initially, or they were already using as per their internal reports, their actual data increased about 35%, but they still reduced their overall costs by approximately 85%. With this, we pretty much come towards the end of the webinar, and thank you so much for joining in. Would love to take any questions, anything you have in your mind on what we are doing. If you would like to know more about Hevo, the product, what's happening on the actual cost saving side, and if you have any inputs on just like that or anything to talk about, would love to take that.
Awesome. Thank you so much, Arav, for a pretty detailed session about how people can save their costs while, making sure that their infrastructure doesn't break. We'll wait a couple of minutes, see if folks have any questions, and if not, we'll conclude the demo days right here. Awesome. Guys, please use the Q&A tab to type in your questions if you have any. Okay, I do not see any questions so far, so let's conclude the session. Again, thank you so much, everybody who has attended so far. We'll make sure to provide you with the deck, the recording, and all, and there's a bonus resource as well that we would want to share with you all. And thank you so much, Arav, for taking out time and walking us through this. All right.
Thank
Thank
you.
you.
Thank you, everyone.